to the next episode of Learning from Home with Mrs. Beckett. Part 2 of the video takes a look at area. So in that first video we looked at perimeter, now we're going to take a look at area. So the formula sheet that is posted in Brightspace will give you lots of guidance in terms of those area formulas. I'm not going to make you remember the formulas for area, perimeter, or even moving forward for volume or surface area. You're going to be able to use this formula sheet on any assessments related to this topic. So remember that perimeter is the outside edges, or it's the measurement of the outside of a shape. But area is the measurement of the inside of the shape. Area is always measured in square units. So instead of just putting meters or centimeters or kilometers, you're going to put meters squared, so the little exponent of a 2. So we're going to use our formula sheet to figure out the area of the following shapes. So the first shape we have is a rectangle. The area of a rectangle is length times width. It doesn't matter which one you put as length and which one you put as width. You're going to get the same answer. So the area is 2 times 5, which is 10, and my units are meters squared. The next shape we have is a square. A square is the same as the area of a rectangle, so you can do length times width, or you could do S squared, where S stands for the length of the side of the square. So area is 3 squared, or the area is 9, and my units are kilometers squared. The next shape we have is a parallelogram. For looking at our formula sheet, the area of a parallelogram is base times height. So the base is right here. The height is the perpendicular height of that object. So the base is 35. The perpendicular height is 12. "35 times 12 is 420. My units are centimeters squared." The next shape that we have is a trapezoid. The area of a trapezoid is A plus B times H divided by 2. So the A is the top length, the B is the bottom length. The H, the height, is the perpendicular height of that object. Okay, so we're going to have 9 plus 15 times 8 divided by 2. Follow order of operations. So solve what's inside of your bracket first. 9 plus 15 is 24. So we're going to have 24 times 8 divided by 2. 24 times 8 is 192. Divided by 2 is 96. So 96, my units are meters, and it's area, so it's squared. The next shape we have is a triangle. The area of a triangle is base times height divided by 2. Again, the base is the bottom of your triangle. The height is the perpendicular height of your triangle. If you have a right angle triangle, then the two sides that form that 90 degrees are your base and your height. Okay, So we're not going to use this, which is called our hypotenuse yet. We're going to be introduced to hypotenuse in a couple of lessons. So the base is 10, the height is 6, and I'm dividing by 2. I can either work on this step by step, so 10 times 6 is 60, and 60 divided by 2 is 30, or I could plug this into my calculator in one step. So 30, and my units are centimeters squared. For part F, I have a circle. The area of a circle is pi r squared. The radius is 4 millimeters. So remember that if you're given the diameter, you're going to have to calculate the radius, and we'll take a look at that in the next one. So pi is 3.14, or you can use your pi button on your calculator, whichever you prefer. If you use your pi button on your calculator instead of 3.14, you might find that your final answer, is slightly different than someone who uses 3.14. Just because you've used more decimal places, your answer is a little bit more precise. So if you're off by a couple of decimal places, not a big deal. So 3.14 times 4 squared. So we have to do our exponents first. So 3.14 times 4 squared, so 4 squared is 16. And then 3.14 times 16 is 50.2 if I keep just one decimal place. My units are millimeters squared. If I'm given a circle and I just have a diameter, so I know that the entire width of my circle is 10 centimeters, then I need to calculate what my radius is. So if the diameter is 10 centimeters, my radius is half of that. So my radius is 10 divided by 2, or 5 centimeters. And now I can calculate the area of my circle. So pi r squared is my formula that I'm using. 3.14 times 5 squared, or 3.14 times 25, because 5 squared is 25. So 3.14 times 25 is 78.5. My units are centimeters squared because it's area. Now let's say we have another circle, but the diameter is doubled. So instead of having a diameter of 10 centimeters, we're going to have a diameter that is twice that, so 2 times 10, which is 20 centimeters. So if my diameter is 20 centimeters, then my radius is 20 divided by 2, or 10 centimeters. And so what does that do to the area of my circle? Well, the area of a circle is pi r squared, or 3.14 times 10 squared. 10 squared, or 10 times 10, is a 100. And 100 times 3.14 is 314. And my units are centimeters squared. Now, what does that mean about the areas of my circles? Well, if my diameter is doubled, what happens to my areas? Well, I'm going to take my larger area, 314, and I'm going to divide it by my smaller area, which is 78.5. And I get an answer of 4. So this means that if my diameter is doubled, my area increases by 4, is 4 times larger. So if the diameter is doubled, the area is 4 times larger. And why is that? Well, because 2 squared is 4. So if I'm doubling something, it's going to change my area by 4 times larger. That's pretty cool. Pause this video. Take a look at part A questions again from Check Your Understanding. This time you're going to do question number 2, A, B, C or F, D or E. You're also going to add on number 3, question A and C. Let me know if you have any questions on Teams and check your answers on Brightspace to make sure you're doing things correctly. All right, welcome back. So now we're going to take a look at the area of composite figures. So when finding the area of composite figures, it is useful to think of the original basic shapes, so the shapes that we can find on our formula sheet, and that were used to create the more complicated figures. So now the areas of the basic shapes can then be calculated, and then we use them to determine the area of the composite figure. So remember that area is always measured in square units. So units could include square inches, square feet, square yards, square millimeters, square centimeters, square meters, square kilometers, whatever. So we're going to sketch the basic shapes used to form each of the composite shapes and then use them to determine the area of the composite shapes by adding those areas together. Now you can divide up your shape however you want to, but it's probably more efficient to think about the least number of shapes that can create that object. So I'm going to divide number 1 in for a long rectangle and a small rectangle. So I'm going to call this shape 1 and this one shape 2. So the area of shape 1, and you'll notice I use a little subscript 1 to show that I'm using this for area 1. So when I'm looking at my calculations, I know what area is going to be for what. So the area of shape 1 is a rectangle, so it's length times width. The length is 2, the width is 10. It doesn't matter if you switch those around. 2 times 10 is 20. My units are centimeters squared. Now I'm going to take a look at the area of shape 2. It's also a rectangle, so length times width. So I'm going to have 5 times 3, which gives me 15 centimeters squared. So now that I have the area of shape 1 and shape 2, my total area is area 1 plus area 2, or 20 plus 15, which gives me 35. My units are centimeters squared. Let's take a look at example 2. So example 2, I'm going to split up like this. So I have a triangle and a rectangle. So we're going to start by labeling them 1 and 2. I'm going to start with my rectangle. My rectangle is length times width. I'm going to use 6 as my length and 3 as my width. And 6 times 3 is 18. My units are meters squared. Now I'm going to take a look at area 2, which is a triangle. Base times height divided by 2. My base is 5. My height is this height right here. I know that this part of my shape is 3 meters, which means that this also has to be 3 meters because this is 6 minus 3, the entire length. Take away this little part is 6, take away 3, which is 3 meters. So the height of my triangle is 3. This is a right angle triangle. So I'm going to have my base, which is 5, times my height, which is 3, divided by 2. 5 times 3 is 15. 15 divided by 2 is 7.5. My units is meters squared. So now I can work out the total area. So I'm going to add up shape 1 with shape 2. 18 plus 7.5 gives me 25.5. My units are meters squared. All right, last example. Let's take a look at this one. I'm going to split this up into shapes that I know. I have a quarter of a circle for number 1, and I have a rectangle for number 2. I know that this measurement right here is going to be the same as this measurement right here. This is my radius of my circle. I also know that this also has to be the radius of my circle. So radius and radius. So keep that in mind as well. So now when I'm looking at the area of my quarter of a circle, I know that the area of a circle is pi r squared. But because I only want a quarter of it, I'm going to divide it by 4. If this was a semicircle, I would divide it by 2. So I'm going to use 3.14 as pi. My radius is 8 squared divided by 4. I have to do my exponents first. 8 times 8 is 64. So I'm going to do 3.14 times 4, which is 3.14 times 64, which is 200.96. I'm dividing that by 4, which is 50.24, or 50.2 if I just keep one decimal place. My units are meters squared. Then I'm going to take a look at the area of my rectangle, which is length times width. I'm going to use 12 and 8, length and width. 12 times 8 is 96. And my units are meters squared. So the total area of my shape is area 1 plus area 2, 50.2 plus 96, which is 146.2 meters squared. Now you're going to take a look at check your understanding questions. So when you're ready, you can pause this video and work on question 4 and 5 from part B. Just do the area only. You've already done the perimeter. Then you're going to take a look at part C, 11A. Again, you're just doing the area only. Ask for help if you need to on Teams. Check your answers on Brightspace to make sure you're doing them correctly. And when you're ready, you can restart this video. The last topic that we're going to look at is area of shaded regions. So to find the area of composite shapes that have pieces removed, we want to find the entire area of the composite piece, and then we're going to subtract the pieces that are going to be removed. Always develop a plan on how to calculate the shaded region using basic shapes. And that plan could include just a plan that you're going to do in your head, or some step-by-step instructions you're going to write down, or it could be a formula. So we want to figure out the area of each shaded region. We're going to go through a couple of examples. So we have a rectangular metal plate is formed by drilling 4 circular holes with a diameter of 2.4 centimeters out of the corners as displayed on the right. We want to calculate the area of the shaded region. So I know I'm going to add in the dimensions of my diameter. So my diameter right here is 2.4 centimeters. Okay. So I know that in order to calculate the area of the shaded region, so the gray section, I need to figure out, well, I'm going to call the gray the entire rectangle shape number 1. So I'm going to take shape number 1 and I'm going to figure out what the area is of that. So if I didn't drill any holes, what would the area of that rectangle be? And then I'm going to subtract 4 of my circles. So I'm going to call my circles area 2. So because my circles are going to be exactly the same, I'm going to subtract 4 of them to get the part that's left over. So that's my plan. Area 1 is subtract 4 of area 2. So that's going to be my total area. So let's start with area 1. So area 1 is my rectangle, length times width. I'm going to use 16 as my length and W as my width, or 11 as my width. So 16 times 11 gives me 176. My units are centimeters squared. Now I need to calculate the area of shape 2. So I know that the diameter is 2.4 centimeters, which means my radius is 2.4 divided by 2, which is 1.2 centimeters. So the area of a circle is pi r squared. My pi is 3.14. My radius is 1.2, and I'm going to square that. So 1.2 squared is 1.44. And I'm going to take my 1.44 and I'm going to multiply it by my 3.14, which gives me approximately 4.5 if I keep just one decimal place. My units are centimeters squared. So I've calculated the area of shape 1. I've calculated the area of shape 2. Now I can put it back into my plan. So the plan was to take area 1, which was 176, and subtract 4 of area 2, which was 4.5. So I'm going to do my multiplication first. So 4 times 4.5 is 18, so I'm subtracting 18. And 176 subtract 18 is 158. My units are centimeters squared. So therefore, the area of my metal plate with the holes drilled out is 158 centimeters squared. And if I wanted to, I could put a therefore statement. Therefore, the area of the metal plate is 158 centimeters squared. So now if I wanted to take a look at this, what percent of the rectangular plate is wasted from the drilling of the holes? Well, I took out 18 centimeters out of my total, which was 176. So let's figure out what percentage this would be. So I know that in order to convert a fraction, so this is the part that was removed, and this was the total area. To go from a fraction to a decimal number, I divide the numerator by my denominator. So 18 divided by 176 is 0.1023 if I keep 4 decimal places. To convert this into a percentage, I need to take my decimal number and times by 100, and that gives me approximately 10% if I keep just a whole number. So 10% of the plate was wasted. Let's do another example. So a piece of sheet metal in the shape below is required to fit around a vent. What is the area of the sheet metal? So sometimes instead of thinking about the total shape and that's given to us, we can sort of add in the piece that would have been cut out. So this entire shape would have been a rectangle. So my plan is going to be, for my total area, I'm going to take the area of a rectangle. I'm going to call that area 1. So this whole thing will be 1. And I'm going to subtract area 2, which is the quarter of a circle. So that's my plan. I'm going to take what would have been the entire piece, if I was to make this into a rectangle, and subtract the part that I cut off. That's a plan that I'm going to use. So let's start with area 1. Area 1 is a rectangle, length times width. I'm going to use 12 as my length, 22 as my width. So 12 times 22. And again, it doesn't matter if you switch those for your length and your width. 12 times 22 is 264. My units are inches squared. Now I'm going to take a look at area 2. So I know that these two edges here are my radius. I also know that my radius is the same as the side across from it in my rectangle. So my radius is 12 inches. So I know that the area of a circle is pi r squared, but I only want a quarter of my circle. So I'm going to divide that by 4. So 3.14 times my radius, which is 12, squared, divided by 4. So if it helps you to sort of think about, okay, if I was to draw this entire circle, this is what it would look like, right? And I'm only using a quarter of it. It's not a very good circle, but you get the idea. All right. So 3.14, I have to do my exponents first. 12 times 12 is 144. I could do this in one step if I want to. 3.14 times 144 divided by 4 gives me a value of 103.0. So just 113 inches squared. So back to my plan, the total area of my shape now is 264 minus 113, which is 151 inches squared. I could do a therefore statement, because this is sort of like a word problem. So therefore, the area of the sheet metal is 151 inches squared. Last part of your check your understanding questions. From the measurement calculations in 2 dimensions, check your understanding worksheet, you're going to do part C. Question 11B, just the area only. You've already done the perimeter. And then you're also going to take a look at question 12A and B. Ask for help if you need to on Teams. Check your answers on Brightspace. When you are finished this, then you can take a look at the Knowledge Hook mission area and perimeter, which you will see shortly. So that was today's lesson on area and perimeter. Hope you learned lots. Remember, you love math.